In this lesson today, we're going to be looking at drawing some transformations. So first thing that we did was looked at a notice and wonder problem. You can pause this video, notice and wonder some things, spend about 1 to 2 minutes noticing and wondering about this screen. And then you can come back to the video and I'll discuss some things that we noticed and wondered in class. So on this picture, some things that we noticed and wondered quite a few different things. And some of it was to do with the different colors that we see. So we saw 3 different colored shapes. We saw, that the shapes were the same shape, but different different sizes. So we saw some different size shapes. In fact, we saw that shape S and M seem to be congruent, but D is larger. Some people noticed that shape S could fit into shape D 4 times. We noticed triangles in the background instead of the normal squares that we're used to on an XY axis. And we also saw that they were equilateral triangles, which then also means that they are equiangular. And discussed that equiangular means that each of those angles is 60 degrees. In each of those triangles in the background, we saw line M. Some people noticed that it looks like shape S is reflected over line M, and that produces shape M. So figure M. Saw O off to the side. So some people wondered, why is O off to the side? Wondered why we've got kind of this dark blue shape and then these 2 are green. Some people noticed that the 2 congruent shapes have the same letters, but we see A, B, C, D, and then we see A and then what's called prime, B prime, C prime, D prime. So noticing this little tick above the A, B, C, D. But yeah, that's pretty much quite a few things that people had noticed and wondered. Definitely not an exhaustive list. You could have noticed other things as well. Some people did notice that E and F were on line M, so they're intersecting there. That was the only shape. Wondered why that one was touching, others weren't. So what we're going to be focusing on in this lesson is these 2 shapes that are the same size. And we're going to be focusing on what's called rigid transformations. So rigid transformations being transformations that move a shape but keep it the same size. So you'll notice that all of these triangles are exactly the same size. They've just been moved. So A to B was translated, B to C rotated, C to D reflected, but the same, every figure is the same size. So then what we're going to do is take a look at an activity on your applet. So when you're on the Learn Zillion slides, then you can take a look at this applet. And a couple of things that I just want to review before we get started on the activity is what I said here for translation. A translation just moves a figure in some directed distance. Okay, so this one is moving down and to the right, this length vector. So every point is moved that far. So it looks like 1, 2, 3, 4 units on the slant. So 1, 2, 3, 4 units will get you to that next one. 1, 2, 3, 4 units will get you to that next point. So translation just kind of slides or shifts the object, but doesn't change its orientation or the way that it's facing. A reflection is going to reflect over a line. So all of the points flip to the other side of the line, but you'll see that they're the same distance away. So this one is one triangle away from the line, and this one's 1 triangle away. Same with these ones. Then this one is 3 triangles away, this one is 3 triangles away. So reflection flips it over. So when you're using this applet, so we're going to be trying to do a few different things here. So what we're going to be doing in this activity is using this applet. So off to the side, you should see these directions. Otherwise, they are in your student workbook on page 68. So using this applet, we're going to look at translating and reflecting figures. So a couple of things on this applet to notice. Okay, so you've got this arrow that then you can kind of move things. You can click on the figure. You can change the color. You can change the transparency of it. So you can get just an outline or you can get it really dark. You can change the size of that outline. You can change it to a dotted outline. You can change it to different things like that. You could add in names, values, captions. Then you can draw points with this, lines. This one, if you're over it, says reflection. We're going to be focusing on this one. Reflections over lines. You could do a reflection over a point, across a circle, rotating, translating by a vector, which we're going to be doing, and dilating. And then this one, if you click on this, you can delete things that you've drawn. So again, we're going to be focusing on reflections and translations today. So I always click on this arrow before I get started. So in this first one, we're going to do translate the figure along segment V. Okay, so if we're going to translate, we would want to pick translate by vector. You'll click on the figure and you'll see it outlines it here. It's a little bit hard to see, but click on that and then click on the vector. Don't click on a point. So don't click on where these like triangles are. Click in the middle of the vector or on the name of the vector. Okay, so you can click on that V or you can click here and it'll just move that shape. Then I would change the color of this so you can see it as different. And then you can draw that into your student workbook as well, making sure that you draw it exactly where it goes. So that just translated each of these by this same length vector. Then it wants us to reflect. So always click back on this arrow. Then it wants us to reflect figure S across line Y. So we'll click on figure S and then we'll click on line Y. Again, not here, not on these little intersections, okay, but right in the middle of the line or on the letter. Whoops. And that's what happens sometimes, is it reflects something different. So if that happens, just click on the arrow, click again, click on the shape, and then click in the middle of the line. Oh, whoops, I reflected the wrong shape. Okay, S. All right, so let's get S. Okay, and then this line. All right, so I wanted to go back to S. Then you can click on this arrow, click on the shape, change the size. And then go ahead and do number 3, reflect figure S. So again, click reflect, figure S, this time over line M. Okay, so here's line M. So that one reflects here. Change the color. Now number 4 has us do 2 things. So translate figure S first along segment W. So translate. Pick the figure along vector W. Now this is not going to go down to vector W. It's just going to go in the same direction as vector W. So 1, 2, 3, 4, 5 units. So it's going to move this figure 5 units down and to the right. Okay, so then click on W. So it'll just move it parallel to vector W. And then it says now reflect this image. So the new figure, reflect that. Okay, so pick reflect the new figure on line Y. So this line. And then this is that final figure. So I'm going to change this one to a different color, but I'm also going to make the transparency. I'm going to make it pretty transparent and increase that line so we can see it, and then change this one to the same color. So you can kind of see your intermediate step here. So we translated it, then reflected it. So then just color that into your student workbook. So you can pause the video, do that. Once you've gotten them written into your book, I want you to take this original image in your student workbook. Okay, so this image S, and I want you to label the vertices just like is shown here. So I want you to label this one as A, B, C, D, E, and F. Then I want you to choose either this image or this one, either of your two reflections from S. So either this top right-hand one or this kind of bottom one. And I want you to label that as A prime, B prime, C prime, D prime, E prime. So wherever A reflected to. So we reflected this over. So we're calling this one A. Let's see if I can change the name. Nope, it's not going to let me. Okay, so then this one would have reflected to here. So this would be A prime. If this is B, then this is B prime, C, C prime. Or if you're reflecting down to this bottom image, A, A prime, B, B prime, C, C prime, and so on. So let me write that out so you can see it. So if you did on this one, you had A, B, C, D, E, and F. So then this one would have gone to A prime, B prime, C prime, D prime, E prime, F prime. Then what I want you to do is connect A to A prime in your workbook with a line. Whoops. Let me get an actual line here. Okay, with a line, so you can take your straight edge, set it down, connect those. If you want to use your pencil, that's fine. You can do dotted if you want to. So A to A prime, F to F prime, E to E prime, D to D prime, and so on. So get all of those connected from the original figure to the image. And then if you take a look here at the original, at the line of reflection, so whichever line you were reflecting yours over, so this figure reflected over line Y. So if you notice these dotted lines here, they're all parallel to one another, and then they appear to be perpendicular to this line of reflection. So here is kind of both figures depending on which one you chose to do, but you can see again all of these connections of the original figure to the image are parallel, and then they look to be perpendicular to the line of reflection. So depending on which shape you drew. So that's what happens in a reflection. The image just flips over, the original figure flips over the line of reflection, same distance away from that line of reflection. And if you were to connect the image to the pre-image, it would be perpendicular to the line of reflection. So image, you keep hearing me say that. So you've got the original figure, and then any transformation of it would be called an image. So original figure, image. So we had S, and then each of these were images of S, or reflections, translations of F, or sorry, of S. All right, then does order matter? So if you click to the next applet here, so in this one, in your student workbook, you're gonna be doing some different movements and transformations of these shapes. As we've been doing this, all of the images that we've been getting have been congruent. So remember, we talked about that a little bit ago, that all of these are congruent. So everything in this last applet, all these images were all congruent to the original figure. And so same thing in here as we start going, what we're going to be looking at here. So I want you to describe a sequence of transformations that will take figure A, it should just say A, onto B. And then you're going to reverse the order and see if it will work. So however you want to do this, but this doesn't look like it's the same orientation. It looks like this, like A has been flipped over to get to B. So you're going to need some type of reflection. So I'm going to start with a reflection, which means that I need a line. So I'm just going to click that line tool and draw a line in here. So then I'm going to want to reflect this figure about the line. So I'm going to click the figure and the line that I just drew. So now I've got my figure and I'm going to click on it and change its color. So now I've got this new image to be in the same kind of orientation as B. Now I just need to slide it over to B. So now we're going to, and this whole thing right here is all your transformations. So now I'm going to go down to translate this shape by a vector. And I can just click on this point. Sorry, I need to click on the figure first. So click translate, click the figure, then I'm going to click on a point and point to where I want it to move. So this is the vector that I wanted it to move on. And then you see that it lands directly on B. So when you're writing this down, okay, you'd want to put this in your notebook. So name this line in your notebook. Okay, so whatever you want, M, make sure you draw it right there. So we reflected figure A over line M. Then we translated it on this vector. So let's name the vector. Okay, and whatever name you want, the computer named this one U. So get that vector drawn in. So that was our movement. So we did reflection over M, translate on vector U, or in the direction of U. So now we want to see if we do this backwards. So if we do the translation first, then the reflection, will it do the same thing? So we're going to do the translation first. So click translation, and we're just going to repeat this on A. So we're going to translate on this vector. So I clicked the shape and this vector. So here's translating it. And then let me just change the color again. Now we're going to reflect it over a line. So we're going to take this shape and reflect it over M. Did it land on B? And the answer in this case was no. Okay, so then you can try and get, using this applet, figure out how you could get A to move over to C. But I do want to show you one thing. I'm just going to delete out all of these and start over. Because there's multiple ways to do this. So you could have drawn your line here. And then we could have reflected figure A over this line. Then translated this new shape. Oops. Translated, so take the shape and then translate it on this vector, moving it 3 to the right, or 3 to the left. So now if I repeat that sequence, okay, so if I repeat that sequence, so I'm going to take this figure, translate it by that vector, so move it 3 to the left, then reflect it, so then take this figure and reflect it over this line, whoops. Okay, then it did land on B again. So sometimes the order of the transformations backwards can work, and other times it doesn't. Okay, so the order of the way you do it does matter. Sometimes it will be the same, but it's not guaranteed to be the same. All right, so some things that we talked about, so you can get this written on your vocabulary chart, is we've got rigid transformations, which is a transformation that keeps the shape and size exactly the same. Some examples are translations, reflections, and rotations. I'm just going to move back to my other screen here so that this is a little bit bigger for you. So examples are translations, reflections, and rotations. These keep the shape and the size exactly the same. So this pink triangle is the exact same size as its image, the blue triangle. When you're marking this down, make sure you get these marks correct here, that you get the exact same marks on the exact same side. So you see 2 tick marks here, 2 tick marks here. 3 in this angle, 2 in this one, okay? So make sure, because there's been some type of reflection and rotation here. So draw these marks exactly. And then same shape and same size is what the definition is for congruent. So it's just figures with equal measurements. The symbol that you'll see is this with equal sign with the squiggly above it. You'll see it right here in this triangle congruent statement where we're saying the original triangle EDC is congruent to triangle E prime, D prime, C prime. So E mapped directly to E prime, D to D prime, C to C prime, and then those measurements are going to be identical. So that is the definition of congruent. All right, then learning targets. So the things that we talked about today was being given a figure and the description of a transformation, that you can draw the figure's image. You can describe the sequence of transformations necessary to take one figure to the next, and that you know rigid transformations result in congruent figures, so same shape, same size.